Welcome everybody, Mr. Vidich here. Today we're starting a new unit on factoring, and most of us have done some sort of factoring in grade 9, so most of this will be a review for you. So we are going to try and do 2 lessons at a time here when we do these videos. Okay, let's get into it, alright? So factoring is the opposite process of what we did last unit, and that was multiplying and expanding polynomials. Okay, so let's go ahead and test that out just to see what I mean here. Okay, so last unit we looked at something like 2x and then times x plus 5. So we would go ahead and distribute that and get 2x squared plus 10x. Okay, so what we're doing this time in this unit is we're going from this, oops, back towards this, okay? And that's called factoring. So going from here to here is called multiplying or expanding, and going back is called factoring. Okay, so let's go ahead and do a few examples down here. Okay, so let's get right into it. So again, so the first example there was 2x squared plus 10x, and that was our result in the first one. So let's see if we can go back to this example right here. Okay, so 2x squared plus 10x. So how do we go back to what we had to start with? Well, the first thing you have to do is you have to find a common factor. Okay, you have to find a common factor, and in this case the common factor to both of these terms, that's term 1 and term 2, the common factor is 2x. Okay, they both have 2 is the highest number that can go into both 2 and 10, and x is the highest variable that can go into x squared and x. So I'm going to go ahead and pull out the 2x. What I mean when I say pull out, what I'm really doing is I'm dividing both of these terms by 2x, like this, 2x, and then writing the result in the bracket. So when I divide 2x squared by 2x, I'm left with x, and when I divide 10x by 2x, I'm left with a 5, with a plus 5, and that is essentially how factoring works, by removing a common denominator. Okay, I'm going to skip the next few examples because we're going to do those in the later lessons, and I'm going to go ahead and just jump right into a few of the examples down below here. Okay, and again, one of the first things we did this year was prime factorization, and that again is going to help us to get the greatest common factor between our terms. Okay, so I'm just going to keep going down. Okay. Let's do example number 2 here. It says, in each case, state the greatest common factor of the following sets of monomials. Okay, so let's first do the coefficients, and that is the 12 and the 15. I can do that one in my head. Okay, the greatest common factor between 12 and 15 is going to be a 3. Okay, and then now I'm going to look at the a's. The greatest common factor when it comes to the a's, well, it's going to have to be 1a, because this term only has 1a. And b's, it's going to have to be there's 3 b's here, or b cubed, and only 1 b, so I'm only going to be able to put in take out 1 b that's common to both. Okay, let's try this one over here. 18 and negative 24. Again, it doesn't matter if the if it's a negative or a positive, you can still remove a highest common factor. So in this case, in 18 and 24, the highest common factor is going to be 6. Okay, I have 4 x's and 3 x's, so I can take out 3. I have y squared and y to the 5, so I can take out y squared. So that is the common denominator. Okay, let's try a few more down here. So let's see this one down here. So this one, the coefficient here is 1. So I can't take anything out. Okay, 1 is going to be my highest common factor. 3 a's here, 1 a here, so 1 a I can take out, or it's common to both. I have 1 b here, and no b's here, so there's no b's that are common to both. And then c squared, c to the 7, so c squared can jump out. Okay, I have 3 terms here. I'm going to find out what's common to all 3 of them. Okay, so I have -40, -20, and -10. So the greatest, so the GCF is going to be -10. I have a cubed, a squared, so a squared is the highest number of a's I can grab. B, 3 b's and 2 b's, so b is the highest number of b's I can grab. I can't, for example, let me just show you this. I can't remove b squared because this first term here only has 1 b. So that's why I'm limited by the lowest number of variables in each term. In this case, that's the only 1 b there. Okay. What do we have here? So factoring a polynomial. Okay, so let's go ahead and do some of these. Make sure you read through all of this. I'm going to skip a few of these just to get right into it down here in example number 3. Because in each case, complete the factoring. Okay, well, what is going to go in the blank here? Well, I'm going to tell you what's going to go in the blank, and that's going to be 7. And the reason it's going to be a 7 is because 7 is the only common factor that can come out of both 21 and 14. And you can always check your answer by distributing the 7 back in. So if I had to distribute the 7 back in, I would get 7 times 3x is 21x plus 14y. And if that matches up with what you have at the start, you factored it correctly. Okay, let's check this one out. So I have 5, 15, and 5. So 5 is my highest coefficient that I can take out. I have x to the 4, x to the 3, x squared. So x squared comes out. Okay, and again, let's check it out and make sure that I can factor, I can distribute that and I get the same answer. So 5x squared times x squared is 5x to the 4th plus 15x cubed plus 5x squared, and that indeed does match up with this left side over here. Okay, moving on. Okay, I'm going to skip example number 4, so see if you can do that one at home on your own, and I'm going to jump right to number 5 here, because that's the whole package in number 5 here. So factor each polynomial by removing the GCF. Okay, well the GCF between 20x and -6 is going to be 2, I believe. So 2, and I'm left with 10x minus 3. Okay, and again, you can always check your answer by distributing that 2 back in. Let's do a few more here. So 16 and 4. 4 is the highest coefficient. X squared, x to the 4, x squared is going to come out. And what am I left with? Well, when I divide 16 x to the 4 by 4x squared, I'm left with a 4x squared. And then when I divide 4x squared by 4x squared, well, I'm just left with 1. This is one of the common places where you could go wrong, is you have to put this 1 here. You can't just leave it as nothing. Okay, it's not a 0, it's a 1, because 4x squared divided by 4x squared gives you 1. So you have to put that 1 over here. Okay. All right, I have a 10, 8, and 2. So 2 is my common factor. I have 3 a's here, a here, a here. So a is going to come out. 2 b's, 3 b's, and 4 b's. So 2 b's are going to come out. Okay, what am I left with? 5 a squared. All the b's are taken out from the first term. Plus 4. The a is gone. And there's 1 b left. Plus 2 divided by 2 is 2. A divided by a is 1. So 2 divided by 2 is 1. So that all the 2's are out. All the a's are out. And just 2 out of the 4 b's are out. So I have 2 b's left. So b squared. Okay. Okay, I'm going to skip this one. You can try that one at home. And I'm going to do the hard one here. All right. I have 25, 20, and 30. So the highest common factor is a 5. Okay, now I have an x here. X squared. X to the 4. X jumps out. y squared, y to the 4, y squared jumps out. 3 z's, 2 z's, 5 z's, z to the 2 jumps out. Okay, now I open up my bracket, and what's left inside that bracket is going to be whatever I, when I divide all the terms, all these terms, 1, 2, and 3, by my common factor, whatever's left goes inside the bracket. So 25 divided by 5 is 5, x divided by x is 1, y squared divided by y squared is 1, z cubed divided by z squared is 1z only. Okay? All right. Then it's going to be a negative 4x y squared. All the z's are gone. Oops, shouldn't close the bracket just quite yet. One more term. Plus 6x to the 3. All the y's are out. And z to the 3. Okay. Hopefully I did everything correctly. And again, you can check it by distributing over here. Okay, let's try the word problem. Example number 6 is the surface area of a cone is given by the formula area equals pi r squared plus pi rs. S is the side length of the cone, where the radius, where the r is the radius of the base of the cone. Okay, so that is the radius there. And the s is the slant height. Determine the surface area of a cone to the nearest 1/100th of a centimeter squared, which has a slant height of 7.4 centimeters and a base radius of 2.6 centimeters. Okay, so I'm going to go and skip this one because we can all just put those numbers in and get the area. So that one's pretty straightforward. But look at the second question. It says here, write the formula for A in factored form. So let me rewrite this. A equals pi r squared plus pi rs. Okay, and now I'm going to factor out pi and the r. So pi r can come out, and what's left? Well, r plus s. Okay, and now the third part here asks you calculate the surface area of a cone to the nearest. Again, the same thing you did in A, but using this formula. And in part D, or in part 4, they want you to compare and see which method was easier. Okay, so I want everybody to do that at home. Use this formula, then use this formula, okay, the factored version of it, and see which way is quicker, or see which way you like better when you find the total area. Okay, lesson 2 here. Okay, binomial common factors. This is the same way you would do as the first one, except now your common factors are binomials. Okay. Let's see how we're going to work with this one. Okay, so let me just give you the answer here. Because they're common, in other words, they're the same, I can take it out, just like I took out in the first part, just like I took out common factors. Okay. What's left is 4x minus 3. Okay, I'll do a few more here. Hopefully you get the hang of it. Okay, so I can take out the 3 minus 2y, and I'm putting a bracket around there because it's a binomial. Oh, there's two terms in there, and 7 plus 2y is left. 4a plus 1 can come out, and 9a plus, here's where you have to be really careful, plus 1, okay, because there's an imaginary 1 there that when I divide 4a plus 1 by 4a plus 1, 1 is left over. Okay, what do we have here? Factor the following and write the answer in the simplest factored form. Okay, so I have 3y plus 2 is my common factor, so 3y plus 2 is going to jump out, and then I'm going to be left with 5y plus 1 plus 4y. Okay, and I'm going to finally finish that off by 3y plus 2. Combine this into 9y plus 1. Okay. Go ahead doing B and C, and I'm going to jump onto D here, and I'm going to factor. Oh yeah, here's a little tricky part for D here, and the reason it's tricky is because they're almost the same binomials, but not quite. This one is x minus 3, and this one is 3 minus x. So even though they look the same, they're not actually the same. So what we have to do is we have to make them the same. How do we do that? Well, here's one way you can make them the same. Let's look at the second binomial, which is 3 minus x. Okay, suppose I factored out a negative 1 from both of these terms. If I factor out a negative 1, what happens to the inside? Well, all the signs change. That becomes a negative 3, and that becomes a plus x. Okay, and now because I'm adding them, I can the order doesn't matter, so I can rearrange them as, that's a negative 1 still, as x plus negative 3 or x minus 3. Okay, so look at what I did here. For by taking out the negative 1, I've made these two terms the same. Okay, there was the first one, there's the second one. Okay, so let's go ahead and do that right now. So 20x minus 3, and that's a negative 4. So I'm going to take out a negative 1. When I take out a negative 1, okay, that's going to be a negative 1 here, and that's going to turn into x minus 3. Okay, let me rewrite this now as 20x minus 3, and negative 4 times negative 1 is just positive 4, x minus 3. And then now, because they're the same, I can take out the x minus 3, and I'm left with 20x plus 4. Okay, so that's a common strategy you can use to make your factors the same. You'll have to do the same thing for this one over here, for the 5 minus x and the x minus 5. Okay, so let's do some more factoring here. Let's do a couple here. I have x squared plus 3x plus 6x plus 18. Factor the following by grouping. Okay, so let's go ahead and do it by grouping. There is no common factor that can go into all four of these terms. Okay, because this one does not have an x on it, and so on. Okay, so here's how we're going to do this. We're going to split this up in half this way and treat each side separately. Okay, so what's common to both x squared and 3x? Well, that's an x. What's left is x plus 3. And now we're going to do the right side separately. So what's common to 6x and 18? Well, a positive 6 is common. What's left is x plus 3. And look at this. I have a common binomial which I can pull out now and completely factor this this polynomial here. Okay, let's do a couple more examples. Try that one. I'm going to skip to this one. So again, I'm going to make a line down the middle here and treat this as the left side and the right side. Okay, so do them separately. So what's common to 8a squared and negative 4a? Well, that would be a 4a. And what's left is 2a minus 1. Here I can take out a 5, a positive 5, and what's left is negative 2a plus 1. Okay, so I have a bit of a problem here. My problem is that these aren't quite the same. Okay, those two aren't quite the same, but they're very similar. So when they're very similar, I can take out a negative 1. Okay, but instead of taking out a negative 1, maybe I should have just taken out a negative 5 instead of a positive 5, and that would have kind of made these two binomials the same. So let me back up a little bit and see what happens when I take out a negative 5. Okay, so I'm going to take out a negative 5 and see what happens. Now this becomes a positive 2a, and this becomes a negative 1. And bingo, okay, my two binomials are the same, so I can pull the binomials out in the front, and 4a minus 5 is left over. All right, let me go ahead and do, you can try this one and this one, and let me see what else is down here just so I can, okay, yeah, let me just jump to this bottom one down here. Okay, so now what are we doing here? So monomial common factor. Okay, so we're just going to do the same thing but with fractions. Okay, so not too much more difficult. Okay, so let's see what happens here. So when I have fractions, again, so if I take out a third here from both of these terms, okay, a third x, well, what's left in this one? This one, the first one's easy. It's an x. But look at the second one. The second one's going to become 12. And here's why. When I distribute this back in, I'm going to get a third x times x is going to be a third x squared. And then a third times 12 is really 12 divided by 3, which is 4. And then x, there's only one x. So there's my answer. And look at that. It looks like the left side over here. So let me do a few more here. Okay. All right, look at this one here. Okay, so 6x plus 2/3. When I factor out to 2/3, okay, well this one is going to be 1. I can tell that fairly easily. But what's going to be on the left over here? That might be a little bit more trickier. Okay, I'm basically going to multiply by the reciprocal and get the answer. So there's the coefficient, and that's a 6. So if I multiply by the reciprocal of the factor, which is 3/2, I should get my answer, which is 18/2 or 9. Okay, let me see if that works. And again, it should be 9x because I did not factor out an x. All right, let's see if that works. Okay, so if I multiply the 2/3 by 9, and then over here, I'm going to get 2 times 9 is 18, divided by 3 is 6. 6x plus 2/3 times 1 is just 2/3. And there it is. Okay, it matches up with the left side. All right, so again, those can get a little trickier, but you can just keep that, learn the rule of multiplying by the reciprocal, and you won't be confused. Let's try this one over here. I have 1/2, I'm taking out a quarter. Okay, so what's left when I take out a quarter from a half? Well, there's a couple ways you can do it. You can just, the reason we're multiplying by the reciprocal is this. Remember, when you're factoring, you're really dividing out your common factor. So 1/2 divided by 1/4 is really 1/2 divided by 1/4, which is really 1/2 times 4/1. So that's what I mean by multiplying by the reciprocal to get the answer. So it's going to be 2 as the answer over here. So it's going to be 2a squared. And then I'm going to do the same thing with with the negative 3/4 here. So 3/4, and I got the negative already, so I'm going to keep it there, times 4/1, and that's just going to become a 3 over here. Okay, let's check out some few more problems down here. Okay, I'm going to go ahead and do the example number 6 here, which is the last example. And again, the reason we're removing fractions is because we don't want our fraction left in the bracket. We want to remove the fraction if we can. Okay, so that's why I always want to try and remove that as the common denominator there. So let's go ahead and remove that 1/4 out of the bracket. It's going to be 1/4, and then I have an a here and an a cubed, so the a is going to come with it. Okay, what's left? Well, 2 times the reciprocal is 8, so that's what's going to be left inside here, 8. And then again, we'll take out a quarter from a quarter. Well, that's just going to be 1 plus a squared. All right. Okay, hopefully that made sense. And let's do the last one here. Okay, so I have 2 fractions now. Which fraction do I take out? Well, I'm going to take out the smaller fraction because that's going to get rid of both of the fractions. Okay, hopefully that makes sense. If I took out this fraction, I would still be left with a fraction in the last term. So let's take out a 1/6x. Okay, and what's going to be left here? Well, it's going to be 6x squared. And now what's going to be left here? It's going to be plus 2x. and then minus 1. Okay, let me go ahead and double check that. I did this one pretty quickly in my head. So if I went like this and distributed 1 over 6, x times 6x is going to just be x cubed. So that's the first line here. The second one is going to be at 1 over 6x plus 2x is going to be plus 2 over 6x squared. And that simplifies to 1/3, so that's correct. And the last one is minus 1/6x, so that one is correct. Okay, so there we go. Okay, I know this video is a little bit longer, but again, we're doing 2 lessons at a time for this next unit. So, and most of the stuff should be review from grade 9 math. So if you're having if you find the stuff a little bit of a review, you can always fast forward through some of the examples. Okay, what I do want to emphasize though is when you're watching this, I want you to do all the examples that I don't do. Okay, and last thing, I know a few people wanted to see my screen cam here as I'm doing these videos. So here we go. Okay, there it is. Hopefully everybody enjoyed that.